Welcome to FICOM World. Today we will learn how to write the chemical formula of ionic compounds. What is an ionic compound? It's nothing but it's a compound which is made up of ions. What is an ion? Ion is a charged atom. You know, atom is a neutral particle. Atom does not have any charge. But when an atom loses electron, it gets positive charge. When an atom gains electron, it gets negative charge. Examples of positively charged ions are sodium ion, Na+, magnesium ion, Mg2+, aluminium ion, Al3+, etc. And examples of anions are chloride ion, oxide ion, iodide ion, etc. Normally, metals are positively charged ions. Metals always have a tendency to lose electron, and non-metals are anions. They always have a tendency to gain electron. So we have two types of ions. One is positive ion, it is also called a cation, and a negative ion, it is also called an anion. So in an ionic compound we can see a cation and anion. Normally the cations are writing first and anions are writing second in an ionic compound. This positively charged cations and negatively charged anions, they attract each other. There is a strong force of attraction between the cation and anion. That force of attraction is called ionic bond. So an ionic compound is made up of a metal and a non-metal. Then how to write the chemical formula? We have to follow some simple steps. The first step, write the symbols of the compound. Example, I am taken here potassium sulfide. You know, potassium has a symbol K and sulfide has the symbol S. So this is the list of anions, and you have to study the anions charge and its symbol also. Chloride is Cl minus, bromide is Br minus, iodide is I minus, oxide O2 minus, sulfide S2 minus, nitride N3 minus, phosphide P3 minus. Here we have sulfide, so we just write the symbol only S. In the second step, we have to write the charge of the ion at the top of the symbol. Okay, here potassium, above potassium we are writing the charge of the potassium. From where we get the charges? Charges we are getting from the periodic table. Periodic table, you can see many vertical columns like this and horizontal rows like this. These vertical columns are called groups. We have 18 groups and the horizontal rows are called period. So in group 1 we have metals, and all of the metal, any element from this group has charge +1. In the second group, any element from this group, all of the elements have +2 charges. Then comes transition elements. They have different charges. Their charges will vary. That I will explain in the next video. So now we leave the transition elements and go into the third group. We have +3 is the charge of group 3 elements, except boron. Boron is a metalloid. So aluminium, gallium, this all have +3 charges. And we have group 4. Group 4 normally makes covalent compounds, so we are not considering group 4 now. Then we have group 5. Group 5 has -3 charge, and group 6 has -2 charge, and group 7 has -1 charge. You have to remember at least this much groups and charges. Now we have to write the charges. So potassium, look, potassium is in the group 1, so it carries +1 charge. We have to write 1 plus or simply plus. Better to write the simple plus charge. No need to write the 1 plus. If it is 1, no need to specify that. And sulfide is an anion. It carries the charge. Sulfide carries the charge 2 minus, means -2. We have to write the charge 2 minus. So this is the second step. In the third step, what we have to do, we have to cross the charges Actually, we are taking the valencies. We are not taking the magnitude as subscripts. Here, potassium has the charge +1. It will go to this side, and sulfide has the charge 2 minus. It will goes to this side. So now K has valency 2. Sulfide has valency 1. So if it is 1, no need to specify that. Now we got the chemical formula of potassium sulfide as K2S. So this is the chemical formula of potassium sulfide. Let's check another example. Lithium oxide. Yes, what is our first step? Just write down the simples. Symbol of lithium is Li. Lithium belongs to group 1. So it has the charge +1. Lithium is Li. Now we have to take the symbol of the oxide. Oxide has the symbol O. Oxide is O. So first we write the symbols. What is our second step? Write down the charges of each symbol. Okay, above the symbol we have to write its charges. So lithium belongs to group 1. So what about the charge? Charge is +1. So we have to write plus only. Oxide has the charge -2. So we have to write oxide charge 2 minus. We never write -2 here. Above the symbol we have to write the charges like this. 1 plus and 2 minus. What is our third step? We just cross its valencies. Don't take the charges, just take the numbers only like this. Okay, +1 goes here and 2 goes here. Now lithium has the valency 2 and oxide has the valency 1. So this is not the structure. Why? Because if it is 1, we don't want to specify the 1. So what is the actual structure? Li2O. So this is the chemical formula of lithium oxide. Then we have to check another example, calcium sulfide. Calcium is a cation, sulfide is an anion. So that is the rule. We have to write cation first, then anion. So calcium, what is the symbol? First we have to write the symbol. Symbol of calcium is Ca and sulfide is S. Okay, what is the charge of calcium? Calcium belongs to group 2, so it carries +2 charge. So we have to write 2 plus. And sulfide has the charge 2 minus, means -2. So 2 minus. What is our next step? Just cross the valencies as subscripts. It comes here and it comes here. Now we have this structure Ca2S2. This 2 represents what? The subscripts tell you the ratio of ions. Means in calcium sulfide, the ratio of calcium to sulfide ion is 2:2. 2:2 is same as 1:1. So we don't want to write 2 and 2. We have to write Ca and S. No need to write Ca1, S1 because if it is 1, we don't want to specify that. So what is the chemical formula of calcium sulfide? CaS. Okay, what about the last example? Sodium chloride. You are very familiar with sodium chloride. It's a table salt. So first step, just write down the simples. Sodium is Na, chloride is Cl. Then second step, we have to write the charges above the symbol. Sodium belongs to group 1. Sodium belongs to group 1, so it carries +1 charge. So 1 plus. So just write plus. And chloride has -1 charge. Chloride ion has -1 charge. So you have to write minus only. Then what we have to do? We have to cross the charges or valencies as subscripts. So Na1, Cl1. Is this correct, students? No. We don't want to specify the 1 here. So what is the actual chemical formula of sodium chloride? That is NaCl. Now we have to check the chemical formula of ionic compound with the polyatomic ions. Here sulfate is an anion, nitrate is an anion, phosphate is an anion. This all are polyatomic ions. What is polyatomic ions? These are the examples of polyatomic ions. Just go through this chart. The first one is NH4 plus, that is called ammonium. It has the charge +1. Then hydroxide OH minus, that is -1. Then nitrate ion NO3 minus, it carries -1 charge, and hydrogen carbonate -1. Then carbonate is -2, sulfite is -2, sulfate is -2, phosphate is -3. Here we can see group of atom carries the charge. So that is the definition of polyatomic ion. They are group of atoms chemically combined each other having a positive or negative charge. Here in NH4 plus, this +1 charge is for nitrogen and this hydrogen. Here OH minus, this -1 charge is for oxygen and hydrogen also. So this oxygen and hydrogen are chemically combined and it acts as a single unit and it carries the charge -1. So you have to memorize this chart. This is the list of very important polyatomic ions. Let's check the examples. Aluminium sulfate. Steps are same. First we have to write the simples. Aluminium, symbol of aluminium is Al. Sulfate. What is the symbol of sulfate? Sulfate is SO4. SO4. This is our first step. We just write down the symbols of the ions, whether it is an polyatomic ion or normal ion, just write down the symbols. Second step, we have to write the charges above the symbols. Okay, aluminium has the charge. Aluminium belongs to group 3, so it carries +3 charge. So we have to write the charge 3+. Now sulfate is a polyatomic ion. Sulfate has the charge -2. So we have to write 2-. Second step finished. What is our third step? We have to cross the charges as subscriptions. So this 3+ comes here, this 2- comes here. Now how we write the structure? Aluminium now carries 2 and sulfate SO4 carries the charge 3. Here if we write the structure like this, it is wrong. Why? Because if more than 1 is the valency, we have to put the polyatomic ion in the bracket. So this is the correct structure of aluminium sulfate. Sorry, correct formula of aluminium sulfate. Let's see another example, calcium nitrate. So symbols, write down the symbols first. Calcium Ca. Nitrate is a polyatomic ion. So nitrate is NO3. NO3. So first step finished. Second step, just write down the charges. Calcium belongs to group 2. So calcium carries +2 charge. So just write down the charge as 2+. And nitrate carries the charge -1. NO3 is a nitrate ion. It carries the charge -1. So just write -. 1- means we are not writing 1. So minus like this. Then third step, we have to cross the valencies as subscripts like this. Okay, so now we have calcium has charge -1, so we are not writing 1 here, and NO3 is the polyatomic ion. It carries the charge 2, so we have to put a bracket, then write 2. So this is the chemical formula of calcium nitrate. In the last example, we have both cation and anion are polyatomic ion. Ammonium is a polyatomic cation. Phosphate is a polyatomic anion. What is the symbol of ammonium? Ammonium is NH4 plus. So NH4 is the symbol of ammonium. Then phosphate is PO4 3-. So PO4 is the symbol of phosphate. PO4. So first step we write down the simples. Ammonium is NH4, phosphate is PO4. Second step we have to write down the charges above the simples. Ammonium is +1, so 1 plus, so we have to write only plus. PO4, phosphate, is -3, so it is 3 minus. So what is the last step? You just cross the valencies as subscripts like this. Now we have NH4. Okay, it carries the charge 3 or valency 3. So we have to put a bracket and write 3. Then write PO4. PO4, no need any bracket because 1 is here. So no need to write the 1. Now the chemical formula of ammonium phosphate is NH4 thrice PO4. Thanks for watching. If you like my video, please subscribe. Have a nice day.